Hi students, today I'm back with the most important chapter calorimetry which every student finds difficult in ICSE, that is the calorimetry. Okay, many students find difficult to understand the concept of calorimetry, especially in doing problems. So I assure you that this is going to be a very useful video. So don't skip, understand every concept and do comment your concerns. Okay, so before going on to the problems, let's first discuss the basic concepts of calorimetry. Okay, so this chapter basically deals with the quantity of heat energy supplied and the quantity of heat energy absorbed during the phase change and so on. Okay, so first of all you need to know the basic equation of calorimetry, which is the quantity of heat absorbed by an object. Okay, so the quantity of heat absorbed or released by an object is always represented by the letter Q. So this Q is directly proportional to mass of the object and Q is directly proportional to delta T. Also Q depends upon the material. Okay, so we can conclude that the equation is Q is equal to mc delta T. Okay, this is a basic and the fundamental equation of calorimetry, where Q represents the amount of heat energy absorbed or given by an object, where m is the mass of the given object and C is called as a specific heat capacity, and delta T is a change in temperature. It can either be a rise in temperature or a fall in temperature. Okay, so Q is equal to mc delta T is a principal equation, where C represents the specific heat capacity. So now the question arises, what is the specific heat capacity? So it can be defined as the amount of heat energy required to raise the temperature of unit mass of a substance. Okay, unit mass of a substance by 1 degree Celsius. Okay, that amount of energy required to raise the temperature of unit mass. Okay, unit mass of a substance by 1 degree Celsius is called a specific heat capacity, C. Okay, there is yet another quantity which is called as the heat capacity. Okay, heat capacity is represented by C dash. C dash is nothing but Q divided by delta T. Okay, the quantity of heat supply divided by the change in temperature gives you the heat capacity. And now we need to know the relationship between C dash and C. C dash is called as a heat capacity and C is called as a specific heat capacity. So we can conclude that C dash, the heat capacity C dash, is equal to C into M. Okay, where the heat capacity is defined as the amount of heat energy required to raise the temperature of a body by 1 degree Celsius, whereas a specific heat capacity is defined as the amount of heat energy required to raise the temperature of unit mass of a substance by 1 degree Celsius. Okay, so that's the basic difference between heat capacity and specific heat capacity. Okay, now moving on to the principle of method of mixtures, or the principle of calorimetry. Okay, suppose let's say we have a beaker which consists of 100 grams of water at a temperature 30 degree Celsius. Okay, and now suppose we add a solid bar of mass 50 gram and it is at a temperature 100 degrees Celsius. Okay, so compared to the water, the added solid is at a higher temperature. So here the two different objects at different temperatures are now coming into contact. So there happens an energy transformation between the two objects, and this object at a higher temperature will surely lose energy or heat energy, and the water which is basically at a lower temperature will gain sufficient amount of energy, and this heat transfer will continue until a steady stage is reached where both of its temperature becomes the same. Let's say that the final temperature becomes 50 degrees Celsius. Let's say that the final temperature becomes 50 degrees Celsius. So it has been observed that the water which was initially at a temperature of 30 degrees Celsius has now absorbed sufficient heat to raise its temperature to 50 degrees Celsius. Okay, so water basically has gained some amount of heat energy, while the object which has been added into the water, which was initially at a temperature 100 degrees Celsius, has lost some energy and it has now attained a temperature 50 degrees Celsius. Okay, so according to the principle of calorimetry, or the principle of method of mixture, it can be stated that the amount of heat energy which was absorbed by water, okay, the amount of energy which was absorbed by water is equivalent to the amount of energy which was lost by the added substance. Okay, so we can conclude that, let's say Q1 is the amount of heat energy which was absorbed by water. Q1 is equal to mc delta T, which is the amount of heat energy absorbed by water. Okay, and let's say Q2 is the amount of heat energy which was lost by the metal piece which was added, which can be written as mc delta T of the solid or the substance which was added. According to the principle of calorimetry, we can conclude that this Q1 will always be equal to Q2. That is, the heat energy which was lost by the metal piece will be absorbed by the same amount of heat energy will be absorbed by the metal piece which was added, so as to attain so that the temperature of the resulting mixture becomes 50 degree Celsius. Okay, this forms a fundamental of solving the questions related to calorimetry. Okay, suppose if it was mentioned if there was mentioned something about the heat capacity of the vessel, you need to consider that also. Okay, suppose if the it contains water at a temperature. Suppose the vessel contains water at a temperature 50 degrees Celsius. Obviously, the vessel will also be at a temperature 50 degrees Celsius. If at all there is in the questions mentioned anything about the heat capacity or the specific capacity of water, you need to take into account that value also. Okay. If it is not mentioned, you can neglect it. Okay. Unless and otherwise specified in the question, you are not allowed to consider it also, okay, in your calculations. Okay, this forms the basis of principle of calorimetry and solving all the problems related to calorimetry. And next portion is the latent heat. Okay, latent heat of fusion of ice. What does it mean? Latent heat of fusion of ice means, suppose you have ice at 0 degrees Celsius. Ice at 0 degrees Celsius. Okay, what happens if you keep it at room temperature ice? It starts melting. Okay, the ice soon melt and reaches to water at 0 degrees Celsius. You should notice that there isn't a change in the temperature. Okay, there isn't a change in the temperature, only there is a phase change. The ice, which was earlier at a solid state, has now melted and has now become to water. Okay, so there is no change in temperature. The temperature is still the same. So only there is a phase change. Okay, so in that case, in such a case, we define the latent heat of fusion. Okay, latent heat of fusion is defined as the amount of energy required to completely melt. Okay, melt the ice into water at the same temperature. Here the temperature does not change. Okay, that is the equation where L is called as a latent heat of fusion, amount of energy required to completely melt and change in another form without any change in its temperature. So here Q can be written as Q is equal to L into M. Okay, so here when ice at 0 degree changes to water at 0 degree, it will absorb a heat energy. Q is equal to L into M. Okay, for ice at 0 to get converted into water at 0, it must absorb this amount of heat energy. Okay, suppose if it is mentioned in the question that ice at 0 degree changes to water at 5 degree. Water at 5 degree. You should remember that the ice at 0 does not initially changes to water at 5 degrees Celsius. What happens is that there is an intermediate process in between. Okay, there is an intermediate process in between, that is ice at 0 degrees Celsius first get converted to water at 0 degrees Celsius. Okay, first get converted to water at 0 degrees Celsius, and this water at 0 degrees Celsius later gets converted to water at 5 degrees Celsius. Clear now? Okay, so here first of all, if you observe that here ice at 0 initially changed to water at 0, so there isn't a change in temperature, there is only a change of phase. So we know that the heat energy Q will be L into M, isn't it? But now this water 0 degrees Celsius is converted to water at 5 degrees Celsius. So there is a change in temperature. So there the amount of energy absorbed is Q is equal to MC delta T. Okay. So here the net amount of energy absorbed is the sum of L into M and MC delta T. Okay. All you need to remember is that ice at 0 degrees Celsius does not instantly get converted to water at 5 degrees Celsius. What happens is that first ice at 0 melt and gets converted to water at 0 degrees Celsius, and there the heat energy absorbed is Q is equal to L into M, because we know that there is a phase change happening when ice at 0 melts completely to water at 0. Okay, there is a phase change and the temperature does not change and it remains a constant. Only the ice which is at a solid state get converted to water which is at a liquid state. Okay, after that water at 0 degrees Celsius get converted to water at 5 degrees Celsius, and obviously there is a temperature change from 0 degrees Celsius to 5 degrees Celsius. Whenever there is a temperature change, the quantity of heat energy absorbed is given by Q is equal to MC delta T. Okay, so in total, the amount of heat energy absorbed when ice at 0 degrees Celsius get converted to water at 0 degrees Celsius is the sum of the two energies, that is L into M plus MC delta T. This is the basic of problems related to calorimetry. If you are once done with this, all the problems will become easier. Okay, so in the upcoming videos, we shall discuss all the latest questions related to calorimetry. Okay, so if you find this video helpful, do like, subscribe and share. Thank you.